J'ai nettoyé le...
Voilà, comme ça, s'il y a des questions, je te passerai.
Okay, I think we can start. So, hello, good afternoon, everyone. You made it to the third day in the afternoon, so we'll try and make the presentation as interesting as possible. So first thing is a little bit of introduction. So myself, I am Sandro Baldi, Commercial Director for NUWARD, the SMR by EDF.
Good afternoon, everyone. I'm Fabrice Tampier. I'm the Product Development Director of NUWARD.
So we are going to have a short presentation with a beautiful video as well to show you. We'll go through a little bit what is our market and our ambition and in terms of internationalization of the product and the market. So first things first, why SMR and how SMR? I think if you participated to a few panel sessions this morning and the last few days, you had already some of the answers. But just to recap, historically, we started with small reactor when we started developing nuclear. And then we moved down to larger and larger reactor. Why is that? The answer is very simple, it's economics. It makes sense to have large installation for the cost of the unit kilowatt hour. So we are not stupid now that we are moving again towards SMR. It's just that the market has changed, the conditions have changed, the needs have changed, new business models, and also because there are new ways, drivers that allow us to gain back the competitiveness. So we are not moving back there, we are moving along this line. And how we do that? Mainly through four enablers. The first one is the modularization and the factory build, which allow us to lower the cost and the plan and the schedule. Secondly, but very importantly, the simplification of the design. So a simpler design, fewer components, easier to construct. Then the very important standardization and series effect. Standardized design means we don't have to change and adapt it every time we cross the border. And therefore, it allows us to have a series effect, deploy multiple reactors across different countries. And harmonization. Harmonization is very much linked to the standardization. Harmonization allows us to have a standardized design because harmonization of regulations means you don't have to completely re-licensed, recertified. This is an ambition. This is something we have to work with the safety authorities, of course. And of course, there are these cross-field enablers with our financing and the international market approach, which we'll come back later on. And now I hand over to Fabrice about the tech. No, we first, sorry, before handing over to Fabrice, a bit on the market. It's important to know what we are targeting. So we target, in terms of electricity generation, three main targets. One is the replacement of the 300, 400 megawatt carbon installations. The second one is ability to supply electricity to remote industrial sites and also energy-intensive sites in municipalities. And third is to supply electricity to grids that have a capacity that is limited compared to if we wanted to install a large power plant. But also, as I was saying, what is new with the SMR is the SMR allow for different business model, and different business model comes with different purposes and end uses. So we are targeting also by design the ability to produce and to extract heat for enhanced thermolysis for hydrogen production, heat electricity cogeneration for district heating, water desalination, and the carbon capture when the technology for carbon capture, direct air capture will be ready. So now, yes, I definitely hand over to Fabrice.
Okay. Thank you, Sandro. So now let's have a look of the key drivers or the key feature of this NUWARD design and what are our main goals. So NUWARD is a PWR generating 340 megawatt with 2 integrated reactors. So it's a mix or combination of proven design and a specific innovation that allow us to leverage of the experience feedback of design, construction, and operation on PWR in France. So what are the main key drivers of the conception? First at all, the safety, the highest level of safety. So NUWARD is meeting the Gen 3+ requirement and the post-Fukushima safety requirements, and as well as all the international standards from WNE, from EUR, and from IAEA. The second main driver is simplicity. Simplicity, that is to say, less systems, that is to say, less component, that is to say, less structure. And it means that the conclusion will be a reactor easy to build. Let me give you some few examples to illustrate the simplicity. First, the reactor is an integrated reactor. It means that all the primary components will be housing in a reactor pressure vessels, the compact steam generator, the pressurizer, the control of drive mechanism will be inside the reactor pressure vessel. A second illustration of the simplicity, we will use passive systems. All the passive systems will manage the DBC accidental scenarios with no need of water, with no need of electrical power supplies during at least 3 days. Another example is a boron-free control reactivity, and we will use in this design a small steel containment immersed in a reactor pool. So that is roughly the main driver for the conception of this design. So better than 1,000 of words, we propose to share with you a video just to share with you an overview of what will be NUWARD NPP. We'll try. just to have a few words about this design. So, NUWARD is a modular design. It means that we will develop in-factory manufacturing and testing in order to reduce the construction period and in order to have less risk for the construction. The other key specificity of this design is we want to standardize this design. We want to standardize the design, to standardize the component in order to benefit series effects. So that is key, as already mentioned by Sandro, just to have a design very simple, to reach a standardized design, and to integrate in this design all the modularity to secure the construction of this kind of reactors.
Thank you, Fabrice. So all this is very beautiful. So when is going to be ready for the market? So we are targeting the ability to commercialize the NUWARD product by 2025. We are today in a conceptual design phase, which will be finished by next year. We also started already the formal discussion with the safety authority in France. Why is that? Because we want to make sure that licensing is not on the critical path of the project, and we want to meet the target date of 2030 for the first concrete on the reference plant in France.
Yes, and at the end of the conceptual design, we will issue a safety option file, which is called in French dossier d'option de sûreté, in order to start the pre-licensing phases.
So how are we doing that? We are not alone. It's very important to have the right support, the right players around you. We have strong support politically and financially by the government. I'm sure you've heard the last few announcements by the government and by President Macron. This is very great. This is great for the supply chain, for France, for Europe, for the very, very experienced supply chain across Europe. It gives visibility in the long term. And also, we, of course, we are basing our development on the knowledge which is at the forefront of technology development for small reactors. And today, we are working closely, of course, with CEA, Naval Group, Technicatom, and Framatome. But, or even more, we were born French, or will develop into become a more European international product. We believe strongly in the international markets. We believe that international market is, in the essence, is essential to develop SMR. There's no single country that can develop a series of SMR to make it competitive by its own. So we need to go across the border. We need to reach out to international players. And that's what we are doing in a three-way approach. First of all, a European core. We are promoting the deployment of European SMR domestic market. And we are calling for the support of the European industry. Secondly, but in parallel, we are working worldwide with a market ambition that goes towards Europe and beyond Europe. So getting in touch with key future countries and customers willing to develop SMR projects, which includes as well industrial players, which is part of the new interesting business model we have for the SMR. And we are promoting cooperation with major players that have significant ability and capability in terms of industry delivery and engineering. And again, in parallel, we are reaching out to the international community to promote the regulatory harmonization and licensing, which is key for the overall market for all SMR out there. And we are promoting policies to support the creation and development of the market. And to show you that we are actually very serious about that, we have announced today the establishment of the International NUWARD Advisory Board, which is a panel of leading experts across research, industry, clients, utilities. They will be there to give us valuable insights and inputs in order to make sure that we don't develop new world for ourselves. We develop the new world for a market that exists for their needs and their purposes. Today, we have some considerable members, as you can see on the screen. We have the Atomic Research Center from India, Ontario Power Generation, UGV Group, part of CES Group in Czech Republic, Fortum and TVO from Finland, Massachusetts Institute of Technology, MIT, the CEA, and Politecnico di Milano, and of course all that supported by the coordination of EDF. Thank you.
Thank you very much.
So we got good 50 minutes for questions. We try to be quick to give more time.
Thank you very much. My name is Hiroyuki Goto from the OECD NEA. My question is, there's many different concepts of SMR. So what is the advantage or strengths of the design of NUWARD compared to other SMR designs?
Yes, you're right. There are many designs. So we need, first of all, about the 70 or 100 design that we can see on the booklet by the IEA. We need to cut down to those that are Generation 3+, because we have a Generation 3+ product, a technology which is proven with some key innovations as explained by Fabrice in order to gain on competitiveness. So if you cut aside only the Gen 3+ and the pressurized water reactor, there are actually fewer players that are ready for the market starting 2030. What is different from us? I would say the difference is actually in the overall team that is actually developing the product itself. It's a team made up of experienced developers. We have built before. We haven't built on the paper, we have built on the field, large nuclear, small nuclear, if we regard at Naval Group and Technicatom. So we've done it before. We got the competencies, and we are reaching out to the international market to give us insights on how we best meet their needs. So this, I think, is the major difference. And behind us, we have now a support politically from France, and we hope very soon, if European Commission gets into a better understanding of the needs and of nuclear, which this is what we understood from the speeches in the first day, that actually European Commission is moving towards a more positive assessment of the interest of having nuclear. I think with the supply chain in Europe and the support, I think we will have quite a strong argument.
Thank you.
Yes, please. Why did you choose to have 2 reactors in one plant? And second short question, what is the refueling process and time frame?
Okay. So this reactor is a result of a long design period. So we started working on it with Technicaton, started for 2010 or before 2010. And we first defined what is our target market. So our target market is to replace, as mentioned by Sandro, the coal-fired plant. So we target a range of power between 300 to 400 megawatts. So we started for that, and then we defined a design in order to reach this target in terms of power. Then we take into account for the design all the experience feedback from PWR in France for the designer, and also from the supply chain. So that's why all these components, all these insights, we converge to this kind of design, 2 units in a a reactor, and which allow us to target and to join this range to 300 to 400. So that is our main insight for this design: optimization of experience feedback, target market, and the know-how of the designer and the supply chain. In terms of refueling, we have refueling 24 months, and the fuel is similar to the fuel to the other PWR. We don't intend to develop a new fuel, and we use for fuel as well a proven technology, so fuel already used for PWR.
Thank you for this presentation. I am Thierry Doucerin from Expert Connect. I would like to have some indications about the dimensions of your installation. It looks very compact. Could you give us some figures about the age of the buildings and the surface occupied by these two reactors, if it is not confidential?
No, it is not. It is not confidential. We already disclosed this information through IAEA document. So just to have in mind that the steel containment is 16 meters high and 15 meters diameters. So you can compare to the larger or middle power reactor. And this steel containment is immersed in a reactor pool, and the reactor pool is roughly a cube, 20 meters. So we will have around 5,000 cubic meters of water in order to have autonomy when we'll have to manage the accident. So that's why we have autonomy for more than 3 days without any action, without the need of water, without need of power supplies in order to manage the accidental situation and scenarios.
And about the surface occupied by all the plants?
Okay, so regarding the layout, you mean the layout?
The layout.
Yes, the layout. So we are in conceptual design. So this the layout will be probably optimized during the future development phases. So for the time being, in several hectares, but we will have to optimize it, especially in basic design, when we will have finished the conceptual design.
Good afternoon. My name is Dalibor Mateu. I am from Moravian Silesian Energy Center from Czech Republic. My question is concerning of the operation of two reactors. Are they operated only like tandem, or it could be operated alone one of them? Like in the case you are refueling one of them, or refueling is on both?
Yes.
In the same time?
Yes, so we don't have to operate the two at the same time. So we can refuel one during one, although the one is in operation.
Bonjour, ça vous dérange pas si je la fais en français? Vous pouvez répondre en anglais. Hein. Voilà, je suis sapeur-pompier et en fait, moi, ma question concerne l'amont et l'aval de la gestion de tout ce qui est TMD, transport de matières dangereuses, en concernant la multiplication de ces installations. Est-ce que vous avez quantifié déjà l'augmentation du trafic, l'augmentation des usines d'enrichissement, combien ça va représenter en pourcentage et la gestion des risques inhérents à ces transports?
Je vais vous répondre en français, puis Sandro pourra traduire la question et la réponse. Donc, pour être clair, hein, on est sur une installation nucléaire. On est sur une installation nucléaire avec les mêmes exigences que l'on a sur nos réacteurs de moyenne ou de forte puissance. Donc ce sera ce qu'on appelle une INB, hein, donc une installation nucléaire de base, qui sera classée au même titre que les réacteurs de moyenne et de forte puissance. Donc globalement, tout l'écosystème associé au management des déchets, au management des risques, au management de la prolifération est exactement le même, avec le même niveau d'exigence.
I'll translate. So the question is about the front end and the back end cycle whether we have already been thinking about that and the risk associated transport, and as Fabrice explained, is actually a standard fuel, standard PWR, known technology, proven technology. So all of the existing measures that are already in place for the large reactor will still be applicable with the proportions, with a small in terms of quantity, of course, in terms of the, waste, for this product, because it's based on proven fuel technology. Do we have a last time for last question? Yes, just one.
Okay. Hello, I'm Murat from Aselsan, Turkey. Actually, I wonder that could you compare the NUWARD technology with the other technologies, especially Generation 4 technologies, in terms of cooling? Yes.
Gen 4. What do you mean in terms of cooling? Whether the requirements are the same, or what is the...
Actually, I wonder that you emphasize that safety.
Yeah, the fact that we don't need to intervention for 7 days.
Yes,
yeah?
7 days. And I wonder that what is the advantage, pros and cons, when you compare with the Generation 4?
Well, the first advantage is that Generation 3 Plus is present today, is available. So we know how to handle, to manage it. We know that there is a long brace period. There is a heat sink for a long time. There's no intervention from outside. For the Gen 4, I would say, let's wait and see when the technology is mature to compare it. But today, we are very comfortable with this kind of parameters. We will please all the licensing authorities and the clients.
Yes, the main difference is the maturity and the time to market, clearly.
Thank you. So we will probably continue in the room. So for final questions, you can come in the little room, and we have another 15 minutes if you want to. Anyway, thank you very much. Thanks.